For some beginning pixel artists, achieving reasonable 3D shading effect could be a challenge. This requires not only spatial imagination, but also a decent understanding of lighting under realistic conditions. All these factors increases the learning cost for artists. Based on this, we propose an interactive shading rendering tool based on physical stimulation of lighting environments, which can take sketches as input and build a set of user-friendly interactions, provide a more intuitive experience for shading. To render a decent shaded image, we decided to use normal maps, which is a common technique for lighting information rendering. Our pipeline starts with a user input, which is then passed into a normal estimator model to initialize a normal map, and generate a shaded image based on these two inputs. Our interactive tool allows the user to change light directions and select areas on the normal map to change its normal vectors, which will then update the shaded result based on the new normal map and light directions. This way, the user can adjust the result in real time to their liking. This is the interface of our interactive shading tool. In our use case, we assume the users already have an unshaded albedo pixel art image available. To start, the user needs to click the Upload button to pass the image into our tool. Once the user has uploaded the albedo image, we will use the model to estimate its normal as an initial state, and generate an initial shaded image based on that estimate. This process may take from 10 seconds to 1 minute, depending on the user's setup. The input image, normal map, and shaded output will be displayed on the UI. The shaded image is rendered using a default light direction, which can be changed by the users. The light source can be dragged around. The light's color can be modified with a simple RGB-based palette. Additional light sources can be added by clicking this button right here. Or deleted using the right-click menu. As users might have different ideas of the image shading from the model, we've added an interactive interface for users to modify the generated normal with a palette-based normal pointer. The user simply select the area they want to modify with a polygon selection tool, select the normal direction they wish to use, and click Send for the corresponding normal area to be changed. Our tool is an exploratory attempt at 2D auto shading process. In the future, our tool will be able to process objects with more complicated geometry or smoother curvature. We will experiment more methods of interaction to provide the users with more freedom and more refined normal editing experience.